Hey there! You know those maths questions in an exam that just look like they're designed to waste all your time? Well, in this quick explainer, we're going to tackle a GCSE problem that seems tricky, but I promise you can solve it in a glance. Seriously, in seconds. Let's dive in.
All right, so here it is. This is the actual question we're looking at, straight out of a recent exam paper. You can see we've got a graph, a couple of lines crossing over, and yeah, the job is to solve the simultaneous equations that these lines represent. It's a classic graphical problem, for sure.
So here's the big challenge I'm putting to you. How do you nail this thing in under 10 seconds? And I mean, forget all that substitution stuff, forget elimination. How do we get that 1 mark super fast? It's not a trick question, I promise. It's all about just seeing what the graph is telling you. Okay, let's break it down. What is this exam question actually asking us to do? So look, here are the equations. But the most important part? The lines are already drawn for you. Think about that for a second. The hardest, most time-consuming part of this problem is usually drawing the lines. And they've just done it. The examiner has basically handed you the answer on a silver platter. This means we don't need to do any algebra at all. We just have to read the graph. Right then, let's get to the core idea here. This is the one simple concept that turns what looks like a tricky question into maybe one of the easiest marks you'll get in the whole exam. Okay, here's the key. The solution to a pair of simultaneous equations, when you've got them on a graph, is just the single point where their lines intersect. That's it. That's the whole secret. That one little spot is the only x and y value in the entire universe that works for both equations at the same time. So, knowing that, where is our solution hiding? Take a look at the graph. Can you see it? And there it is, hiding in plain sight, right? It's the exact point where the two lines cross over. This is such a great example of how a question that looks like it's going to be heavy on the algebra is really just about reading a chart. The answer is literally just that one spot. Okay, so all we've got to do now is figure out the coordinates of that point. You know the drill. We'll trace down to the x-axis to get the x value, and then trace across to the y-axis for the y value. All right, let's start with the x-coordinate. If you put your finger on that intersection point and trace straight down to the horizontal axis, the x-axis, boom, you land right on 6. So x is 6. And now for the y-coordinate. Go back to that same point where they cross, and this time trace straight across to the vertical axis, the y-axis. And where do we land? Yep, -2. So our y-coordinate is -2. And that's it. We're done. The solution is x equals 6, y equals -2. How easy was that? No crazy algebra, no long calculations. We just read the graph. Okay, but don't just take my word for it, right? Let's check out the official mark scheme to see the proof. This is what the examiners are actually looking for. And here we go. Have a look. Question 9. The answer is x equals 6, y equals -2. Exactly what we found. Now, see that little code next to it? B1 and cow? Let's quickly talk about what that means because it's super important. So, B1 is basically an accuracy mark. It means you get the point for the correct answer and that's it. You don't need to show any working out at all. And CAO, that just stands for correct answer only. It's the examiner's way of saying, nope, this is the only answer we'll accept. So for a B1 CAO mark, all you had to do was write down the right numbers. That's it, full marks. All right, so let's boil this all down. If you take away just one thing from this whole explainer, please let it be this one golden rule. Here it is. The solution is simply the point of intersection. That's the golden rule. If an exam question gives you the graphs, the answer is always where the lines cross. Just find that spot, read the coordinates, and you've banked those marks. It really is that simple. So I'll just leave you with one final little thought to chew on. What if the lines were parallel? You know, what if they never ever cross? What would that mean for the solution? Something to think about. Anyway, thanks for joining this explainer, and all the best with your revision.